Hi, this is the demo for our CSC416 Intelligent Agents TileWorld assignment. So in this video, we will be presenting the experiments we conducted, as well as the different strategies we explored and that we implemented. Before we begin the actual experiment, let's just take a look at the setup for the demonstration. In the center, we have the actual environment grid. Uh, in the grid, we can see the blue agent, which is the Hannibal agent with its properties described on the left pane. The red agent is the faceman agent and its properties are on the right pane. And at the bottom, we have the console with some basic notifications about messages and backtracking. On the grid, again, we have green cells, which are the tiles, the pink cells, which are the holes, and the black cells, which are the obstacles which the agents cannot go over. We conducted two experiments. In the first one, both agents could explore the entire environment, whereas in the second one, they were localized to predefined areas of the environment. We implemented a basic if-else strategy for the agents to decide which tiles or holes to pick up. The highest priority is given to tiles or holes within the agent's sensor's range. If there aren't any, it checks its memory, as well as asks the other agent for tiles and holes in its vicinity. Of these two, whichever is closer, it goes to them. Finally, if that does not work out, it generates a path to a far random location and explores that location. We will explain each of these as we encounter them in the demonstration. This is our initial experiment using configuration 2. As you can observe, both agents are exploring the entire environment and picking up tiles and holes as they go around. Now we're going to slow down the time so that we can watch the red agent drop a tile and pick up a tile. The red agent doesn't have anything in its vision field, but it's going towards a hole from its memory. It drops the tile and the hole disappears, and the number of carried tiles is now 0. Now another tile has appeared, it picks it up, and it's looking for a hole or another tile. It finds another hole and it's going to move towards it, and the tile has been dropped into that hole. And now it's going towards the other tile and picking it up, and we can see the numbers changing on the pane on the right. Yeah. Now we're going to let the simulation run at the fast speed again till 5,000 steps. And at the end, we'll see that the blue agent has a score of 357 and the red agent has a score of 305. And in this first experiment, we've covered the agents picking up and dropping tiles from their sensor range as well as from consulting their memory. Now we come to our second experiment, which is also what we implemented finally. In this experiment, the environment is divided into two halves, and each agent is largely localized to one of the two halves. For square grids, we're dividing the environment into two triangular halves along the principal diagonal. We've drawn an orange line to show the diagonal, and the blue agent is located in the bottom half, and the red agent is in the top half. This is configuration 1, and as you can see, the tiles and holes are appearing at a much lower rate, so we expect an overall lower score for this environment. Now we're going to slow down the video again and watch as the two agents track back to refuel as their fuel level drops below the set threshold. You can see the agent's positions moving and the fuel level decreasing. The GUI on the right pane seems to have frozen because of some bug, but now they reach the fuel station and they refuel, and the fuel level is back to 1000, and they start exploring the grid once again. The threshold is based on the distance of the path back to the fuel station, as well as accounting for any other obstacles that might occur in the way, as well as any tiles or holes that the agent might find in its sensor range. Now we let the simulation run to 5000 steps, and at the end the scores are 33 and 39. We're also taking a look at the memory for each of the two agents. Since we're decaying memory, it doesn't store everything, it only stores a certain number of recent items. This is the simulation for configuration 2. It's a 50 by 50 grid, and the tiles and holes are appearing at a much faster rate, so we expect a very high score for this simulation. So in this simulation, we can see that the agents are using message passing and factoring that into their decision-making process. In our implementation of message passing, the agent sends a list of 3 percepts, which are either tiles or holes depending on what the other agent needs, and they're sorted by closeness to the other agent. In our implementation, the agents are polling each other for messages. Now we'll watch this simulation till 5000 steps. It's the same configuration as the very first simulation with the addition of the diagonal, and we can see that the agents are sticking to their own zones and exploring largely their own zones. At the end of this simulation, the scores are 307 and 321. Now we come to our last configuration. This is a rectangular grid of 150 by 40. So for rectangular grids, we have implemented the division into two halves along the vertical center to keep things simple as there is no principal diagonal. This grid is quite a sparse grid in terms of tiles and holes, so we expect the score to be relatively low. In this configuration, the dividing line is ignored when the red agent needs to track back in order to refuel, since the fueling station is in the other agent's territory. As can be seen, at the end of this simulation, the scores are 10 and 10. This brings us to the end of our video demo. Thanks for watching.
A rude boy don't play with the bomb, the dang, the